Hi everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if we can truly measure how smart a kid is, even in places far from fancy labs, and if what we measure actually matters for their future? Well, scientists Joseph Coffey and Elizabeth Spelke asked themselves a similar question. They wanted to create a way to test how children in low and middle-income countries were developing cognitively, especially in areas that might predict later success in school. Think of it like building a special toolkit for understanding a child's developing mind, but one that works everywhere, not just in a quiet, controlled room. They wanted to see if they could take clever games and puzzles, the kind used in psychology labs, and make them work for kids in places like Ghana, where life is often noisier and the environment very different. So, how did they do it? They designed a whole set of tests, like a big assessment battery, that could be used with children from about 1.5 years old, all the way up to 7.5 years old. These tests weren't just about memorizing things. They were based on things psychologists already knew were important for thinking, like understanding numbers, navigating space, using language, managing your own behavior, and even understanding what others might be thinking. They wanted to see if these core skills that seemed to be there from a very early age and across different cultures could be reliably measured. To test their toolkit, they used data from over 1,000 children in Ghana. These kids' parents had previously been part of a big study about education. The researchers wanted to see if their new tests could actually pick up on differences in how these children were developing, and if those differences were meaningful. They paid special attention to making sure the tests worked in Ghana. This meant using local people to help administer the tests, making sure the materials were familiar and engaging for the kid, and adapting the tests so they could be used outdoors or in busy homes. They even changed some of the materials, like swapping out candy for toffee, to make it more relevant. They were really careful to make sure the tests were understandable and fair for the children. Now, for the exciting part, what did they find? It wasn't all smooth sailing, especially with the youngest children. For the 1.5-year-olds, the tests were a bit shaky. The overall consistency of the tests for the 1.5-year-olds was quite low. This means the results for different tasks for the same child weren't always similar, making it hard to get a clear picture. Also, fewer than half of the children were performing above what you'd expect, just by chance, meaning the tasks might have been too hard or confusing for them at that age. But when they looked at the 3.5-year-olds, things started to look much better. Almost all the kids were performing above chance, meaning they understood the tasks much more. The tests for this age group showed good internal consistency, meaning the different parts of the test for, say, language tended to measure the same thing. And importantly, how well kids did at 3.5 years old could predict how they would do on similar tasks at 5.5 years old. This is a big deal because it shows these tests might be measuring something stable about their development. By the time the children were 5.5 years old, the assessment battery was working really well. The overall internal consistency was high, meaning the tests were reliably measuring something. Most of the children were performing well above chance. And by 7.5 years old, the battery was even stronger. High rates of above-chance performance, strong internal consistency, and good predictive validity were observed across most domains. This means the older the children, the more reliable and useful the tests became. So what is the takeaway? The researchers found that their assessment battery was pretty good at capturing stable differences in how children performed on tasks related to language, numeracy, spatial reasoning, and executive functioning, especially for the older children from 3.5 to 7.5 years old. This is a huge achievement. They were able to show that even in challenging field settings, it is possible to create tests that are internally consistent and can predict future performance. They did notice that the tests for the youngest children, the 1.5-year-olds, weren't as reliable. They think this might be because very young children respond more slowly, get bored easily, and can be more easily influenced by their surroundings or cultural norms, like whether it is considered polite to take more toys or fewer. This is a really important point for anyone trying to assess young children in any context, but especially in diverse cultural settings. The study also highlighted how important culture and context are. Even though they tried hard to adapt the tests, things like children's comfort with unfamiliar adults, their familiarity with different media like laptops, and their experience with preschool could all influence how they performed. This isn't a flaw in the tests themselves, but a reminder that when we measure development, we're always doing it within a specific cultural and environmental context. Overall, this research suggests that using lab-based experimental methods to create assessment batteries for children in low and middle-income countries is a promising approach. These tests can capture meaningful differences in children's performance and can be used to evaluate interventions. They've made all their materials and data public, which is fantastic because it means other researchers can use them. adapt them, and build on this work. It is a step towards making developmental science more inclusive and understanding children's potential no matter where they grow up. This research is a testament to a lot of hard work and collaboration, involving many researchers, surveyors, and institutions. It shows how important it is to get it right when we're trying to understand how children develop. This paper is part of a growing effort to develop more robust and culturally sensitive measures for child development research. It's a big step forward in making sure that children everywhere have their development understood and supported. The fact that the older children's performance could predict later performance is particularly exciting for understanding long-term impact. Imagine being able to accurately track if an educational program helps kids develop skills that will serve them throughout their lives, even in a busy village or a lively home. What I find really compelling is how the older children's results were so strong. When the assessment battery showed high internal consistency for the 5.5-year-olds, it really means the tests were reliably measuring something consistent about their cognitive abilities. And when almost all of them performed above chance, it suggests the tests were largely understandable and accessible to them. This makes the battery a much more powerful tool for older age groups. It is also really interesting how some domains performed better than others. The fact that language, numeracy, spatial reasoning, and executive function all showed adequate internal consistency for the 5.5-year-olds is great news. These are core skills that are often targeted by early childhood interventions. However, the very low internal consistency for mental state reasoning in this age group suggests that these particular tasks might need more work or adaptation to reliably measure theory of mind in this context. Even within the older age groups, individual tasks can be tricky. While the overall battery might be reliable if only a few specific tasks within a domain meet the criteria for internal consistency, it means those are the ones you can trust the most. The fact that more than 2/3 of children performed above chance on a good number of tasks is positive. But it also means that some tasks might still be challenging or less effective for capturing individual differences at this age. This is probably the most important finding for the practical application of this research. A large association between performance at 5.5 years and 7.5 years means that how a child performed on these tests when they were younger is a good predictor of how they'll do on similar tests a couple of years later. This is exactly what you want in an assessment tool if you are trying to see if an intervention is making a real, lasting difference. It suggests the battery is measuring skills that develop and persist over time. By age 7.5, the battery is performing exceptionally well. The high internal consistency and the near universal above chance performance really indicate that the tasks are reliable and understandable for children at this age. In this context, this age group seems to be the sweet spot for this particular battery. This study is a fantastic example of how we can adapt sophisticated scientific tools for use in diverse settings. The fact that they managed to create a battery that is sensitive to individual differences and increasingly effective with age is a major win for developmental research in low and middle-income countries. The biggest strength here is the open-source nature of the material, which will undoubtedly accelerate research and intervention efforts globally. The main limitation, as they clearly state, is with the younger children where the tasks might need further refinement. They also rightly point out that future work needs to establish stronger links between their battery, other established assessments, and actual school performance. This would give us even more confidence in what these tests truly measure and their long-term predictive power. I think this research opens up so many possibilities for understanding and supporting child development worldwide. It shows that we don't have to rely solely on assessments developed in Western contexts. By focusing on core cognitive abilities and carefully adapting methods, we can create powerful tools for research and intervention in any corner of the world. It makes me excited to see how this battery will be used and further developed. What do you think about these findings? Do you have any experiences with developmental assessments? Let me know in the comments below. If you found this video interesting, please give it a like and subscribe to RUBIN'S Mind Lab for more deep dives into the world of psychology. Thanks for watching, and I'll see you in the next one.